Chapter 18, Quality Control for CT Scanners. For CT scanners, quality control may be defined as a program that periodically tests the performance of a scanner and compares its performance with certain benchmarks or standards. Essentially, there are 3 steps to a CT program. Acceptance testing is the first step, which verifies the compliance as to whether the scanner meets the manufacturer's specifications and ensures that it operates efficiently in terms of various outputs, such as image quality requirements and dose output. The acceptance testing is usually done by medical physicists, and it ensures that the scanner has mechanical and electrical integrity, stability, safety of various components, and CT dose and imaging performance. Examples of acceptance testing could include verification of slice thickness, CT uniformity, CT number linearity, spatial and contrast resolution, noise, and dose output. Routine performance is another step to a QC program, and this refers to monitoring the components of scanners that affect dose and image quality. Monitoring includes QC tests that are performed on a daily, weekly, monthly, and yearly basis. Techs are pretty active in routine performance evaluation of the scanners, but some of these tests do need to be completed by a physicist. The ACR and International Atomic Energy Agency has specific tests that they suggest to be done by the CT techs and specific tests that should be performed by solely the physicist. Take a quick look at these specific tests on page 432 and 433 of your book. The next step is error correction, which deals with the evaluation of the results of the QC test. If the scanner doesn't meet the acceptance limits established for a particular test, then the scanner must be serviced to ensure that the acceptance limits do get met, so the errors are corrected. QC testing requires the need for test tools and phantoms, which are used to conduct the actual test, and there are categories for these phantoms and pieces of equipment. The first is the image performance phantoms, which verify the performance of the CT scanner on image quality characteristics such as high and low contrast spatial resolution and noise. Geometric phantoms use tools to measure the spatial resolution accuracy and the laser accuracy. Dosimetry phantoms are used to assess the CT dose output, and this includes the CTDI. And the quantitative CT phantoms measures the accuracy of these CT numbers. There are 2 types of phantoms that are used regularly, and one is the ACR CT accreditation phantom. It is used for the American College of Radiology's voluntary accreditation program, which demonstrates to patients and personnel operating the CT facility the safety and effectiveness of their CT imaging services. This phantom is based on solid water construction to ensure stability and reproducibility of QC tests conducted over time. It consists of 4 modules that measure positioning accuracy, CT number accuracy, slice thickness, light accuracy alignment, low contrast resolution, CT number uniformity, and high contrast resolution. The CATFN 700 Phantom was designed for the Phantom Laboratory. It includes 3 solid cast test modules positioned inside the housing of the Phantom, such as the sensitometry, slice geometry module, the line pair per centimeter module, and a low contrast sphere array. And this slide just shows the 2 different types of phantoms that we just discussed. So obviously the ACR accreditation phantom is on the left, and you can see the 4 different modules. And then the CATFN phantom is on the right. There are 3 basic tenets or principles of quality control. First is that QC must be performed on a regular, periodic basis. Now, it would be ideal if this was able to be done after each patient to have maximum assurance that the scanner was always operating correctly, but this would take way too much time, especially time away from the next patient. It is up to the facility as to when they perform what tests. Quicker tests can be performed on a daily basis, and more time-consuming and less important tests can be completed less frequently, maybe monthly. The most complex tests could be done semi-annually or annually. Another principle is prompt interpretation of measurements. So data performed from the QC test shows that the scanner is operating correctly or not within the guidelines. When it isn't performing within the guidelines, action obviously has to be taken. The person making the test must be able to recognize when the results are outside of the acceptable limits. So acceptable limits must first be set, and then when the tech takes a look at the results of the test, he or she then recognizes right away that the results are outside of the limits. Some programs even have the techs enter the measurement data for QC tests into the computer, which then the computer does the recognizing to see if the measured data is outside the acceptance limits. But if this is the case, then the tech must enter the data into the computer right away and not wait a certain amount of time or any time at all and collect a bunch of data and then enter it all at once. Faithful bookkeeping is the third tenet or principle. Since time and effort are put into performing the test, then the test should be recorded, such as in a logbook, data form, or a computer for a reasonable amount of time. Usually this is done for the lifetime of the scanner. These recorded results will come in extra handy if the scanner seems to be malfunctioning on a recurrent basis. The data from record books have also been used to come in handy in order to defend lawsuits that may arise from the reading of a CT image. So for example, if the CT scanner can be removed as a source of blame for a misinterpretation or misdiagnosis, because it will provide the scanner was performing optimally and wouldn't have produced a subquality image that may have caused a misreading, and then that can take the CT scanner out of the equation for the blame. Now we will discuss some details of testing procedures, the equipment required, interpretation of the results, and some suggestions for acceptable limits and how often the test should be performed. The selection of techniques for the QC test depends on the type of CT scanner and the test being performed. A range of variables can be selected for each test, and these include peak kilovoltage, milliamperage, scan time, slice width, type of algorithm, type of X-ray filter, and focal spot size. It is important for the technique for a test to remain the same from day to day, but the technique for one test doesn't necessarily mean it should remain the same for a different test. As a general rule, the chosen technique should match that of a frequently used technique. One way to do this is to choose the most frequently used head or body technique and use it for all tests. Then, as many tests should be performed using this technique, yet knowing that deviations may be required for certain tests. Test priority and test frequency. So, as we said on the last slide, it is usually necessary to limit the more complex tests to annual periodic testing frequencies. It is also important to repeat appropriate tests after the replacement of a major component, like an X-ray tube, or after there has been a significant amount of servicing to the scanner. But also, if a facility uses their scanner to largely perform tests that deal with localizing tissues, as in biopsies or radiation planning, then it might be a good idea to increase the frequency of these tests so they are performed more than annually. Limits of a passing test. So what are acceptable limits for tests? The change in the variable between measurements is very important to take into account. So a scanner that is operating the same today should be operating the same the next day, or at least very similarly, especially as far as testing goes. After performing the test, a quick look at the measurements will tell you if the results are deviant or not. It is always good to compare the values against what the regular values of the testing of the scanner have been for a specific test. There are two performance standards for QC test results, which are acceptable and achievable. Acceptable results indicate that the performance must be within certain tolerances, and if it isn't, then the equipment shouldn't be used. Achievable results indicate the level of performance that should be attained under favorable circumstances, which is, as we discussed a little earlier, the ACR CT accreditation QC test program requires the use of the ACR Phantom and the QC tests using the 4 modules that make up the Phantom. Remember, these tests measure positioning accuracy, CT number accuracy, slice thickness, light, accuracy alignment, low contrast resolution, CT number uniformity, and high contrast resolution. But also, CT number linearity and radiation dose must also be included in the testing. Linearity is refers to the relationship in CT number to the linear attenuation coefficients of the object being imaged. Remember, we discussed this a little bit in chapter 9. For radiation dose, the CTDI volume is measured, and it should be either a pass or fail result depending on the protocols being measured. A visual inspection is when a checklist of items is used to record the status of the scanner components. The ACR assigns this task to the tech, but the IAEA assigns it to the medical physicist. The ACR says that the visual inspection should be performed on a monthly basis and should include certain items, but the IAEA has a different checklist of items that should be evaluated. Check out the differences in the visual inspection list on page 440 of your book. Regarding artifact evaluation, the ACR also requires the CT tech to be able to identify and correct image artifacts from a water phantom on a daily basis. These artifacts include both streak and ring artifacts, and we also discussed this a little bit more in depth in chapter 9. So there are 18 quality control tests that are popularly performed, and the book outlines them all in depth and in detail. And I also included these in my PowerPoint slide as well for chapter 18. I'm not going to go over each of them just because it would add to the length of this video and be very lengthy. But I do want you to look over them in the book and also maybe on the PowerPoint slides as I outlined the specific details and the important factors regarding them.